Have you ever wondered what would happen if we landed on Uranus? It's a question that tickles the human curiosity, a testament to our fascination with the universe and the unknown. Throughout history, we've made countless attempts to explore the cosmos, from the first telescope to the footprints we left on the moon. But what if we push those boundaries even further? What if our next step was on a distant ice giant? Let's embark on this imaginary journey to the seventh planet of our solar system, Uranus. Uranus, the ice giant, holds many secrets yet to be unveiled by mankind. Its enigmatic nature has long intrigued astronomers and space enthusiasts alike, beckoning us to delve deeper into its icy realms. Nestled within our solar system, the seventh planet from the Sun, Uranus, is a spectacle of cosmic proportions. Its sheer size is staggering. 4 times the size of Earth, Uranus is colossal, dwarfing our home planet with its imposing presence. But it's not just its size that sets Uranus apart. This distant world is unique in more ways than one. It orbits the Sun on its side, a peculiar tilt that mystifies scientists to this day. This unusual axial tilt means that a single season on Uranus can last for over 20 years. Imagine experiencing a winter that lasts for 2 decades. Yet, the most fascinating aspect of Uranus is its composition. This ice giant is aptly named, for it is indeed a world of ice. A thick, frigid layer of water, ammonia and methane ice envelops the planet, casting it in a pale blue hue that is characteristic of Uranus. Beneath this icy exterior, a dense atmosphere of hydrogen and helium shrouds the planet, adding to its mysterious allure. But don't let the term ice giant mislead you. The temperatures on Uranus are far from what we consider icy. The planet's outer atmosphere boasts a chilling -200 degrees Celsius, making it one of the coldest planets in our solar system. This extreme cold, coupled with the planet's gaseous nature, creates a world that is both breathtakingly beautiful and incredibly hostile. Uranus, with its icy surface, gaseous atmosphere and unique tilt, is a world unlike any other. Its alien landscapes and icy realms are a testament to the diversity and wonder of our universe, a reminder that there is so much more to explore and discover. Now, imagine if we were to land on this icy gaseous giant. The journey to Uranus is not just a simple rocket ride. It's a voyage into the great unknown, pushing the boundaries of human capability and technology. This journey is no small feat. It's a cosmic marathon, an adventure that will take us approximately 2,600,000,000 miles from our home planet. The first challenge we encounter is the sheer timescale of the journey. Even traveling at an average speed of 56,000 miles per hour, it would take us around 9 years to reach Uranus. That's nearly a decade in the vacuum of space, far from the comforts of Earth. This brings us to our second challenge, the need for supplies. Supporting a crew for such a long journey requires careful planning and innovative solutions. Traditional food and water supplies would be insufficient. Therefore, we must develop sustainable systems for food production and water recycling. But the challenges don't stop there. We'll also be contending with the harsh conditions of space. Think about the intense radiation from the sun, the zero-gravity environment, and the extreme cold as we move further from our sun's warming rays. These conditions demand the pinnacle of technological advancements. We'll need spacecraft with advanced propulsion systems to make the journey faster. We'll need shielding technology to protect us from harmful radiation. We'll need spacesuits and habitats that can withstand the cold of space and yet remain flexible enough for humans to live and work in. And then there's the mental challenge. The psychological toll of such a long journey, isolated from Earth, cannot be underestimated. It will require astronauts of exceptional mental fortitude, prepared to face years of solitude and confinement. In the face of these challenges, one might ask, is it worth it? But remember, each challenge presents an opportunity for innovation. It's a chance to push the boundaries of what we know and what we can do. Having overcome the hurdles of the journey, what awaits us on Uranus? Now that's a question worth answering. As we inch closer to this possibility, we continue to dream, to innovate and to explore, for that's what makes us human. Landing on Uranus is unlike landing on any other planet we know. No, it's not your everyday stroll in the park. Imagine trying to land on a colossal ball of gas, where a solid surface is a concept as elusive as a mirage. So let's delve into the complexities of setting foot on this icy giant. First off, the notion of landing on Uranus is somewhat misleading. You see, unlike Earth, Mars or the Moon, Uranus doesn't have a solid surface to land on. The planet is primarily composed of swirling gases and ices, making it more akin to a vast frigid ocean, only without a discernible surface. Now, this doesn't mean landing is impossible, but rather it requires a different approach. Think of it as diving into an ocean, rather than landing on a runway. But don't let the analogy fool you. This is no ordinary dive. The pressure and temperatures are extreme, and the environment is anything but hospitable. Life on Uranus, as we know it, would be drastically different. Imagine a world where the sun seems eternally on the horizon, where the sky is a deep blue with faint bands of white clouds, where diamonds are as common as sand. Welcome to Uranus. The first thing to note is the extreme cold. Uranus is an ice giant with surface temperatures dipping to a bone-chilling -200 degrees Celsius. This is far colder than any temperature experienced on Earth, and it would require advanced technology to keep us warm and alive. Now let's talk about the ground, or rather, the lack thereof. Uranus is a gas giant composed mostly of hydrogen and helium with a small rocky core. The planet's surface, as we understand it, is a dense fog of supercritical water, a state of matter that is neither liquid nor gas. Walking on Uranus, therefore, would be more like floating or flying. Next, the weather. Uranus has an incredibly dynamic atmosphere with winds that can reach up to 900 kilometers per hour. These winds whip around the planet, creating spectacular light shows as they interact with the methane in the atmosphere. But these weather patterns would make life challenging, to say the least. Lastly, let's consider the time. A year on Uranus lasts for a staggering 84 Earth years. That's a lot of birthdays to celebrate. And with a day lasting about 17 hours, we'd have to adjust our sleep cycles accordingly. Living on Uranus would be a life of extremes: extreme cold, extreme winds, and extreme time. It would be a world where the familiar rules of Earth do not apply, where we would have to adapt and evolve in ways we can barely imagine. It would be a world of beauty and mystery, of diamonds raining from the sky, of sunsets that last for years. Living on Uranus would certainly be an adventure like no other. Our journey to Uranus may just be a flight of fancy, but it underscores our curiosity and desire to explore the unknown. This icy, distant world, with its peculiar tilt and swirling icy clouds, is a testament to the mysteries that still lie within our own solar system. The journey there would be fraught with challenges, from the long duration of the trip to the extreme cold and high-pressure environment. Yet, despite these difficulties, the potential for discovery is immense. The unique characteristics of Uranus, from its methane-rich atmosphere to its potential ocean of water beneath the surface, offer unprecedented opportunities for scientific research and exploration. It's a place where we could learn more about the formation of our own planet, and perhaps even discover evidence of microbial life that could revolutionize our understanding of biology and evolution. But Uranus is just one of countless celestial bodies in the vast expanse of the universe, each with its own unique characteristics, mysteries, and potential for discovery. From the roiling storms of Jupiter to the potential for life in the subsurface oceans of Enceladus and Europa, the universe is full of places waiting to be explored. As we continue to gaze at the stars and push the boundaries of our knowledge, who knows what we might discover next?